Greetings!
I am Hans Dingal,
I am Monique Esmile.
I'm Rina Marie Fiestada.
And together, we are the Trace Minerals.
We are here
to introduce to you
The three minerals
you've never heard of before.
WXZ minerals! First, let's talk about Wolframite. Its chemical formula is manganese iron tungstate. It belongs to the class sulfates and the subclass tungstates. Its color is black to gray or brown. For the luster or the mineral's ability to reflect light, it's submetallic to resinous. Submetallic meaning that the luster is like that of mineral but it's duller and less reflective. And resinous meaning that its appearance is like resin, chewing gum, or smooth surface plastic. Next will be the transparency. It's translucent to opaque. Next is the cleavage or the tendency of minerals to break along definite smooth planes. It's perfect in one direction and parallel to the ANC axis. For the mineral's hardness, it's 4 to 4.5. The hardness of a mineral is its resistance when being scratched. This is based on the Mohs scale of hardness. While the next one will be its specific gravity or the relative weight of the mineral to an equal volume of water. For Wolframite, it's approximately 7.0 to 7.5, meaning that it's heavy even for metallic minerals. Lastly will be the streak or the color of the powdered mineral. It's brown to black. You might be wondering, does it look like a wolf or something? So the question is, why the heck is Wolframite its name? The name of the mineral was derived from the German word Wolfram, which when translated to English means wolf's froth or cream. No one is definitely certain when it comes to etymology, but it seems to be reference to the consumption of large amounts of tin during the extraction phase of the mineral, which could be associated to a wolf eating a sheep. W is from wolfram, thus it became the symbol for tungsten as a chemical element. Next will be the origin of the said mineral. Wolframite is usually found in granite and pegmatite dikes and is often associated with cassiterite. It also occurs in sulfide veins and placer deposits. Moving along to the uses of Wolframite. Wolframite is highly valued because it's the main source of the metal tungsten. Along with scheelite, the Wolframite series are the most important tungsten ore minerals. Due to tungsten's characteristic of being strong and dense, also the fact that it has high melting temperature, it's an ideal material for armor-piercing ammunition and electrical filaments, as well as hard tungsten carbide machine tools. This is because heat causes tungsten to expand at about the same rate as glass. The metal is widely used to make glass to metal seals, resulting for tungsten or its alloys to be used for filaments for electric lamps, electron and television tubes, electrical contact points for automobile distributors, heating elements for electrical furnaces, and space, missile, and high-temperature applications.
We will talk about the mineral Xenotime next. Its chemical formula is yttrium phosphate and belongs to the class of phosphates. Its color is most commonly various shades of brown, but also gray, greenish brown, muted red, and yellow. Its luster is vitreous, which refers to a glossy luster, and resinous, like that of Wolframite. Its transparency is from translucent to opaque. Its cleavage is perfect in two prismatic directions. Its hardness is 4 to 5 on the Mohs scale, which is between fluorite and apatite. Its specific gravity is approximately 4.4 to 5.1, which is heavy for translucent minerals. And its streak in its powder form is pale brown to yellow or red. Sino nga ba si Xenotime? The name is from the Greek word meaning vain honor, because the yttrium in Xenotime was mistakenly thought to be a new element. Occurring as a minor accessory mineral, Xenotime is found in pegmatites and other igneous rocks, as well as gneisses, rich in mica and quartz. It may contain radioactive elements in its structure and therefore may have some level of mild radioactivity. It frequently forms together with zircon. Xenotime is used chiefly as a source of yttrium and heavy lanthanide metals, namely dysprosium, ytterbium, erbium, and gadolinium. Occasionally, gemstones are also cut from the finer xenotime crystals. It is also said that xenotime helps balance the metabolism of potassium and can be useful in eliminating cellular parasites. Also of note is that xenotime is one of the few phosphate minerals that does not contain water molecules, hydroxides, and chlorides. And hey, now you know a new word that starts with the letter X.
The last mineral is the mineral zircon. It is a chemical formula of zirconium-4 silicate. Its class is silicates and subclass nesosilicates. Its colors are brown, red, yellow, green, blue, black, and sometimes colorless. Its luster is adamantine, which is like in a diamond. It has a high refractive index, from 1.9 or higher. Its transparency is from transparent to translucent. Its cleavage is distinct in two directions, or prismatic, which can form crystals. Its hardness is 7.5 Mohs, which is between the quartz and the topaz. The specific gravity is 4.6 to 4.7, and it's strict, or when the zircon is powdered, it will produce a color white. Let's first tackle the etymology of the zircon mineral. In 1800s, some say that it came from the German word zircon, which spells the mineral with K instead of C. But nowadays, its etymology is jargon, or vague mineral, meaning that its name has uncertain origin. Now, let's talk about on how the zircon minerals are formed. For the past 2,000 years, zircon minerals are mined from thin gravels or aggregation of rocks. But nowadays, zircon minerals can be found by doing simply surface mining or dredging zircon-rich sediments. These sediments can be found in beach, littoral deposits, which can be found in sea or lake, and alluvial deposits, which can be found on rivers. Now, let's talk about the special feature of the zircon. Zircon is highly resistant to chemical alteration and abrasion. What is abrasion? Abrasion is the scraping or the wearing away of minerals. So why is it highly resistant to chemical alteration and abrasion? This is because of the hardness of the zircon mineral, which is the 7.5 in the Mohs scale. So when zircon minerals are weathered and eroded, it became a tiny zircon crystals that persist on soils, sediments, and sedimentary rocks. These soils, sediments, and sedimentary rocks can undergo several cycles of uplift, weathering, erosion, and deposition. And after those cycles, the zircon can still survive. Now for the last, let's talk about the purposes of the zircon minerals. Its most famous and the most common purpose is that it became a gemstone for over 2,000 years. It has a high refractive index, making it as a rival of the diamond. And its color can be colorless, making it as a substitute for a diamond. Also, zircon has a low expansion coefficient and is very stable at high temperature. And because of this, zircon minerals can be used to produce ceramics. That's all for the zircon minerals.
WXZ Minerals!
I am Hans Dingal,
I am Monique Esmile.
I'm Rina Marie Fiestada.
and together we are the Tray Mineral.